Holy moly, I am almost 1 minute late. It is. It's still 22 hours UTC. Hey, welcome everybody. Now it's 22:01. Hey, how's everybody doing? What's up? Everybody's doing well out there. Welcome once again to Astronomy Discourse live. So, yeah, hope everybody's doing well out there in the universe and the world. Things are good here. Things are just chugging along as they normally do down here in southeastern Arizona in the United States. I'm 7 hours behind UTC, so at least according to my clock, it's 3:01 p.m. on the 5th of September, 2019. It's just chugging along here. We've got a few more days, a couple more weeks until the equinox, and wow, it's just things are moving along quickly. So yeah, I hope everybody's doing well. I hope you can hear the music in the background. Let me know one way or another. So yeah, this is just a casual, almost daily, not exactly daily live stream where we come together, friends from around the world, and we sit back, relax, grab our consumables of choice. I once again have the hydrogen hydroxide in here, the HOH. Great stuff. It isn't quite as good as homebrew, but it's adequate. It's adequate. So cheers. All right. Ooh, not much left in there. Hopefully there won't be any kind of crisis with that. So yeah, as I said, everything's good here. So on this live stream, we sit back, relax, and chit chat for, I don't know, an hour-ish or so. Sometimes a little bit less, sometimes just a little bit more. Sort of depends on what's going on at the moment. The one thing I can say about astronomical topics is that there are so many of them. My task here is to try to figure out, maybe the one or two things to sort of talk about today. So, so in addition to that, if you have any ideas in terms of topics, let me know, because that's what this is all about, is sharing the passion. And this live stream is for everyone as well. It's for the beginner who knows nothing about astronomy and science at all. It's for the amateur astronomer. It's for the advanced amateur, and it's for the professionals. This is for everyone, but it is sort of a place to come and just sort of relax and just sort of chill. We're not gonna, this live stream is not here to answer questions. Okay, what this live stream does is it questions answers. So there are always a lot more questions that is going to come out of this than any kind of answers. Hey there, Tom. Nice to see you in the chat. Hope everything's well over there in the Midwest. Yeah, everything's good here. But yeah, there are a lot of astronomy and science YouTube channels that you can go for answers, it makes me uncomfortable giving answers out, because I know as a scientist that there's too much uncertainty, even in things that we think we're sure about. There's just a lot of uncertainty in that, and to be able to answer anything with any kind of certainty, to me at least, is really not incredibly responsible. You know, um, in the old days, they had the high priests, and so when you had any kind of answers, to questions, you would run to the high priests, and the high priests knew everything because they were literate and they studied things, and all the minions and everybody else didn't. So they had to go to the high priests for the answers. Well, the modern day high priests, sad to say, are the scientists. The scientists have made this claim that they have the answers, and so come here and ask us things, and we will give you answers. And yeah, I have a hard time with that. What you'll get here is you'll get a lot of questions, and I try to keep it at a very, very high level. I'm not trying here to simplify things. I'm not trying to speak in English. I'm trying to elevate everyone, and the way to do that is to reach, right? So a lot of the things that we talk about here go way over my head, right, way over, generally speaking, that's how things are. But just because they're going over your head doesn't mean that you can reach up a little bit and maybe grab on a little bit and pull yourself up, to begin understanding these kinds of things. So that's what I like to do here. Instead of trying to take sort of really, really complex topics, maybe, and I mean, there's no better word, dumb them down so everybody can understand them. I don't really like to do that. I would like to make everybody a little bit smarter so they can rise up to these levels instead. And that's what I do, and that is what I've done my entire life, is try to reach. So that's what this live stream is all about. So yeah, let's get into it a little bit here. Let me grab another gulp of this. Hopefully the audio in the background is okay. I'm gonna look and see what's playing right now. Okay, cool. All right, well, great. So, well, I think what I want to do today, for a little while at least, cheers, is let's try to finish up NGC 5576, that pretty interesting elliptical galaxy over in the constellation of Virgo, sort of on the eastern side of Virgo in this case. So let's do that. I'm going to pull up my Simbad again, because what I started doing yesterday and where we're going to go today is we're going to continue looking at some of the papers that are supposedly referencing this object. So I'm doing a Simbad search, and I'm going to come down and I'm going to display all the references, and then there we go. Okay, so now I will share the browser and do that like this. Ready? There it is. Excellent. So I'm going to go over here, and yeah, let's just sort of go through this, because I'm kind of interested, like I said, in there are 291 references, scientific papers that supposedly mention this object, and I'm kind of curious. That's a pretty large number of references. So I'm kind of curious as to, you know, why is this object so seemingly so exciting? And I guess one of the answers that we got sort of early on here is that there's dust. People are pretty interested in dust, not only, you know, inside of these galaxies, but also between us and these galaxies. So I think we got all the way down to here with Dustpedia, which Uncle Bill was actually kind enough to post a link to sort of the main site over on my Discord server. You can find an invite to the Discord server down in the description of this video thing. So make sure to get onto that if you so desire. So yeah, let's just keep looking here and see if there's anything else. Oh, the yawning has begun. You know, it is definitely a more relaxed state when I begin to yawn, because the only time that I yawn is when I'm like really just mellow and relaxed and everything else. So yawning is a good sign. Feel free to yawn. I understand that it's not because you're bored. It's because you're just relaxing. You're chilling out, and that's what a lot of this is too. It's just let's just sit back, relax, sort of forget about the rest of the world at the moment. There's always insanity going on. Let's just forget about that and think about NGC 5576. That's pretty amazing. Very, very large elliptical galaxy. So, okay, H-alpha imaging observations. Early type galaxies just mean that they as with a lot of things in astronomy, they're sort of backwards thinking, or yeah, that kind of thing. So an early type galaxy is actually an old galaxy. You know, they came out early in sort of, you know, the evolution of the universe, supposedly. So yeah, you know, we're thinking that elliptical galaxies are old because they used up all of their dust and gas in the formation of stars and whatever else. Now, you know, whether that's true or not, I don't know. You know, we make observations, we try to create models, simulations, and we run those. We get some results, and we compare them to the observations. And if they match really, really close, well, okay, then maybe we're pretty confident in the models. And the models are saying that elliptical galaxies are evolved. They're old, and because we're astronomers, we have to do things backwards, and so we call them early types. So, all right, systematic search for tidal features. Now, you know, that's one of the interesting things that I noticed about this particular galaxy. I don't know if you noticed it or not, but when I'm looking at this thing, I am sort of seeing something funky over here. You see, I mean, it's got a nice elliptical shape, but then it's got something funky going on over here. So it sort of looks like, look, which one did I? Oh, yeah, it's down here. Can we do this? Yeah, I can do this. So this is enhanced Sloan digital sky survey imaging of the local volume. they call it. I don't know if I've ever heard of the local volume. That's kind of an interesting term. But yeah, let's see what enhanced imaging looks like. Again, this is pretty recent stuff, so let's just dive into it and see. Because I'm kind of curious now to see exactly what enhanced imaging, looking for tidal features. Um, let's just look up our little galaxy friend here, NGC 5576. Looks like another sort of big paper. I'm not surprised. These papers, I don't know if it's me or if it's something else, but they're just getting bigger and bigger and bigger. It's like, how do you read all this stuff? 16 pages. So just looking at the abstract. The abstract is supposed to be sort of a very, very, very brief description of the paper. It's sort of like an executive summary. This group, the astronomy and astrophysics folks, they've sort of expanded on that, and they have these different sections of abstracts now, where there's a context, there's the aims, there's the methods, there's the results. Anyway, so yeah, let's okay. So it's saying in hierarchical models of galaxy formation, stellar tidal streams are expected around most, if not all, galaxies. Okay. Okay, let's we can just sort of dive into this a little bit. Yeah, so they're just talking about various surveys and whatnot, but probably what we should do is just dive into this a little bit and see. Okay, so here's just an example of an enhancement technique for NGC 4414. You can sort of see what's going on there. Let's see, the field of view for each panel is 30 arc minutes on a side. Okay, so you sort of get an idea of scale here. So let's see, the original Sloan Digital Sky Survey image is on the left. The middle is the final results of their processing with an inverted grayscale, showing the extent of a conspicuous shell of debris. Ooh, southwest of the central galaxy. Southwest, isn't that over here? I don't know if I see anything or not. Kind of hard to tell, I guess. So, all right. Well, let's keep going here. Probably not going to get too much into it here, but we'll try. Examples are very faint, diffuse over densities of different types. So giant stellar warps of a galactic disk, 5506. I guess that's what they're calling a stellar warp. Number 2, a stellar ring with two seemingly interacting, partially disrupted cores embedded in it. So yeah, something supposedly has gone on there to spread these out like that. There seems to be some weird stuff over here too. Let's see, number 3 is an image artifact resembling a giant galaxy. Wow, so this, I guess this smudge here really isn't there. And let's see, extensive galactic cirrus. So that's just, you know, stuff out there. Wow. So yeah, you know, they're very, very, very much overexposing, you know, the sensors of these things to bring out this other stuff here. So, well, cool. Yeah, you know, it looks like they're sort of describing things a little bit. Okay, yeah, so here's some, I don't know what STSS is exactly. We can probably find out. What is it, section 2.4.1? Oh, 2.4.1. Oh, the Stellar Tidal Stream Survey, STSS. So this is just overlaid. So they've taken the images from the Sloan Digital Sky Survey and just plopped them on top of STSS. This tidal, what is it called? The Stellar Tidal Stream Survey. Oh, okay, and I guess here they're just showing just the survey parts. So you can see that you know there's a lot more to these galaxies than what you might think. And I just have to add that if you were to go out tonight and look at this galaxy with your telescope, you would probably see sort of this area right here, maybe a little bit of the fuzz around here, but it would seem like a small, faint, fuzzy blob. Maybe a little bit of a shape, but that's about it. So, you know, by eye, we can just sort of see, you know, this brightest area here. We might be able to see this bright star. This is likely a foreground star. You can see the diffraction spikes there from the telescope. But yeah, you know, with a larger scope and a longer exposure and, you know, some filters, you can get the Sloan Digital Sky Survey image. And then if you go even deeper, which just means a longer exposure, wow, you start seeing all kinds of interesting structures way out there. Look at that. It's almost like there's a hard edge there with this weird cylinder of stuff. Wow, that's pretty cool. But none of these are showing our galaxy. Let's see if I did. Well, I'm about halfway through. Let's see if it shows it at all. Because, you know, a lot of these, all of these here look like spirals. These look like spirals too, to a certain extent. So, okay. I mean, our guy is definitely an elliptical. Okay, yeah, they're showing that there are some ellipticals. Not too many, but it shows that there are 10 of them, at least here. So, okay, well, let's keep going. Okay, so here's some more. 681. It's kind of neat to how they're overlaying these. That's kind of a neat thing to do. Well, don't see it there. Although 7742, wow, that looks like an elliptical. We'd have to find out exactly. 4203 looks like an elliptical, maybe. Again, kind of hard to tell. 718, 936. These all look like, you know, various kinds of either spirals or irregulars. 4762. Look at that. Isn't that amazing? Look at that stuff flying off of there. So, again, this is a foreground star. This is a foreground star. Most of these black dots are going to be foreground stars. This is either some kind of a weird flaw on the camera itself. I doubt it's anything like an asteroid or a satellite, because it's going to be about as wide as these faint stars, and as you can see, that's very narrow. So it's probably like a cosmic ray, or yeah, it's hard to know. Okay. Conclusions. All right, so they're not showing them all here. They'll probably list them. Let's see if 5576, yes, it is. Possible diffuse shells, they say. So, tidal streams found in this work. What is this? Oh, okay. Galaxies with no evidence of diffuse over density. So yeah, it looks like they only found a few. I mean, well, what, page and a half, where they found a few, and dang, we sure that we didn't see them in here anywhere? I'm going to do a search. 576. That looks like that's the only time it's mentioned. Yeah. None of these. I would hope they're showing all these cool pictures. I wonder if somewhere in here, and I'm gonna check the chat here again. Uncle Bill, hey, nice to see you. Oh, I don't know, Tom, about mergers and whatnot. Yeah, things like that are really, really complicated, I would say. What at least I was taught was that ellipticals are like evolved galaxies, and that earlier in their lives they may have been spirals, and over time they eat up all their gas and dust, and so there just isn't any more. But yeah, I think the possibility that there's some kind of a merger. Yeah, that's as good as explanation as ever. I of course am not really up on these kinds of things, but yeah, it's very cool regardless. But yeah, I'm sort of bummed that they don't show an actual image of 5576 here. They show a whole bunch of other ones. But yeah, we're not seeing. Yeah, that's just 441. Not seeing it there. I think we went through this already, so I'm not gonna get into this too much. But it sort of looks like that's the only time that our little galaxy is mentioned, which is a bummer. Let's see. Tidal stream candidates. Nope, not seeing it there. Not seeing it there. Nope. So yeah, for some reason they list them, right? Tidal streams found in this work. And there he is, 5576. Is it the only elliptical? Oh, there's another one. 4494 is an elliptical. So they found two ellipticals that have these tidal streams. 4494, was that one of the ones that we looked at earlier on? 4494. Maybe they show that one. I'd like to see an elliptical. They're not going to do it, are they? Nope, they're not. 7742 looks elliptical. Huh. 7792. Oh, yeah. Well, okay. Well, let's keep moving here. Let's see. Can we go back? Yeah. So interesting. It has dust. It has some kind of tidal thing going on. Bivariate luminosity, pure bulge galaxies. So here's Galax again. Study of central light concentration in nearby galaxies. Central light concentration. Huh. So I guess that's just how much it's brightening as you move towards the center, something like that. Monthly notices of the Royal Astronomical Society. Probably what that means. Propose a novel technique to estimate the masses of supermassive black holes residing at the centers of massive galaxies in the nearby universe using simple photometry. Sextractor is employed to determine the central intensity ratio at the optical center of the galaxy image for a sample of 49 nearby galaxies with SMBH mass estimations. Supermassive black holes. Yeah. Okay. Let's see if we can. Well, let's just look for our guy, of course. There he is. Let's see what this table is here. List of properties. Okay, so we've got distance in megaparsecs, CIR. I don't know what CIR is. CIR. What? I don't know what happened there. CIR. Oh, central intensity ratio. Central intensity ratio. So let's keep zooming in. I don't need to zoom in. I need to do this. I want to know exactly what the central intensity ratio is. Okay, so the central intensity ratio is defined as this. I1 and I2 are the intensities, and M1 and M2 are the magnitudes of light within an inner and outer aperture. Okay, so they've and I don't know if they'd show a picture of that or not, but they've done some kind of aperture photometry, and you know the inner part is 1 and the outer part is 2. So that ratio is just 1 divided by 2 minus 1. Okay. So if 1 say is twice as bright as 2, so the CIR would be 2 divided by 2 minus 1, which is 2. Cool. And you can, use magnitudes instead. Flux and magnitude have a relationship there. So, okay. So that's that. So what is it for our guy here? 1.13. 1.13. So effectively, the central area is only 1.13 times brighter than sort of an outer area. Let's see. Okay, so this supposedly is their estimate in terms of the mass of the black hole in terms of 10 to the 8th solar masses. So you take this number and you multiply it by 100 million. So in our case, our little guy is 1.6. So that's what, 160 million solar masses. Okay. And just for a comparison, if it helps, which I don't think it will, but the Andromeda Galaxy's so-called central black hole is 140 million solar masses. So this sigma, let's see, what's sigma reference? I guess that's stellar velocity dispersion. So this is just, it's sort of a measurement of its, I guess, its rotation speed. So that's sort of on the low end. If you look at these, 182 kilometers per second. Okay. Yeah, the half-light radius, I think that is just, when going from the center outward, it's when the brightness has decreased by a factor of 2, and this is in parsecs. So we can look at that. 3,254.7 parsecs. So you gotta multiply that by 3.26 to get the number of light years. I'm going to pull up my calculator here on my computer, which is very, very bad, but that's what I've got at the moment. Multiply that by 3.26, you get 10,610 light years. Okay, what's this next one? Okay, so this is just, it's the logarithm of the mass of the galaxy, so in terms of solar masses. So what you can do here, you see how it says 10.58? You can, again, pull up your calculator, which I'm going to do again, because I just got rid of it. And there's a 10 to the x function. So if I do 10.58 and then do 10 to the x, that will tell us how many solar masses. And this is saying, wow, that's a lot. 38 billion solar masses. So it seems like a lot. It's, oh, they don't have one for M31. I don't know, that seems a little light. Because our galaxy is estimated to be like 400 billion. So this is like a factor of 10 less massive than that. So, okay. Age, they have age in terms of billions of years, and some of these are kind of funky, right? We've been told by the high priest that the age of the universe is something like 13.8 billion years, giga-years old. But here we have a galaxy that is 17.7 billion years old. Do we have an age for our galaxy? Yeah. So NGC 5576 is just a youngin at 9.1 billion years old. So, yeah. Oh, here's even a younger one. Wow, look at that. NGC 4889. Okay, well, cool. Do you have any more references to 5576? No. That's it, huh? I'm gonna look at the chat again really, really quick. Yep, good. Everybody's just following along. Excellent. Okay, well, let's keep going here. In slow rotator. Slow rotator. So maybe this is a slow rotator. Demise of faint satellites. Yeah, that previous paper that we were looking at before, looking at the tidal things, we would have thought that if there are any kind of satellite galaxies around that you might be able to see them that way, and just the quick glance that we did, we didn't see anything. So here's the Chandra survey. Chandra, of course, is an X-ray satellite, so looks like they probably looked at it. Wonder what it. I don't think that they would have an X-ray image of it here in the paper. Maybe though, I don't know. Black hole activity in the quiescent regime. Loss revisited. Unraveling correlations between supernova rates. I wonder if there's ever been a supernova observed in this galaxy. It's possible. Systematic trends and total mass profiles. Nibbles. N-I-B-L-E-S. Cosmic Flows 3. Don't quite understand what that would be. Supermassive black holes and their host spheroids. The Symphony Black Hole Survey. So, everybody thinks that there's a black hole inside of NGC 5576. Constraints on the feedback in the local universe. Supermassive black holes and their host spheroids 3. So, yep. X-ray halos. X-ray halos. I wonder if we got anything there. That's the Astrophysical Journal, 2016. Let's see if we can see any X-ray halo images here. Chunk. Studies of the physical properties of local elliptical galaxies are shedding new light on galaxy formation. Here we present the hot gas properties of 33 early type systems within the massive galaxy survey that have an archival Chandra X-ray observations. Cool. Let's do a lookie. Yeah, there he is. What is this? So that's just the position in the sky, alpha and delta, in degrees. So you have to convert this to hours and minutes and seconds and whatnot. Distance in megaparsecs. Radius, I guess, in arc seconds. R sub E. Let's see what that. Yeah. Optical effective radius in arc seconds. Here's the velocity dispersion, and they say measured at that radius. So these are the stars or things way out on the edge. I think that's how I would interpret that. L sub k has to do with luminosity, and again, it's a logarithmic scale, so it's in terms of solar luminosities. It's yeah, a lot. Now here they've got a different mass. They're calling this the mass of the halo at 12.3. Remember, the previous paper had it, what, around 12.6 or something like that, or 10.6. So here's 12.3. That's a lot. 12.3. 10 to the 12.3 is, ooh, yeah. That's 2 trillion. Is that right? Million, billion, yeah. 2 trillion solar masses. Woo-wee! I don't know what this delta RE is. Let's see what that, if we can figure that out. 2D galaxy rotation parameter. I don't know about that one. Ellipticity. So that's just how elliptical it is. I would sort of assume that a value of 0 would probably be completely round, and a value of 1 might be, extremely elliptical. So again, 5576 is around 0.306. So it's pretty elliptical. But let's see if there's any, oh, there's no images or anything. It's just a list. Wow, it's really short. Okay, well, not seeing much here in terms of pictures, but how do we get to the end? Not quite sure what we're seeing here. Oh, was there a dropout in the thing? Andy, nice to see you. Yes, you must remember the new time. Double twos. Double two, 22 hours. So, I'm not sure what we're looking at here. Because only some of them are labeled. Well, that's not very nice. Look at that. Some of these are labeled and some of them aren't. Give me a break. 55. Yeah, see, I'm not seeing them there either. X-ray data. Huh. Yeah, I'm not seeing anything there. Massive X-ray sample. Huh. Well, that's a little curious. Not quite sure what to make of these images here. They don't seem to show them all. A little annoying. (5353). Let's look at that list again. It's only there. 5353. Yeah, I don't know what's going on there. You have to sit back and sort of interpret this a little bit. Yeah, they're really hot hot to be talking about supermassive black holes. So for some reason, that's what they think is all exciting about this thing. Tim Robinson. Yeah, it looks like I'm buffering a little bit. I'm not exactly sure why, but yeah, everything's good. Glad you could stop by. New time, new location. So yeah, I don't exactly know why I'm buffering as much as I am, but well, hang with me as you usually do, and we'll get through this okay. So we're looking at an elliptical galaxy called NGC 5576, and it's been extensively studied, huge, 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 and so we're just sort of going through everything um, like we always do, and see if there's anything interesting. This galaxy seems to be a black hole candidate. Everybody's pretty excited about those kinds of things. And I'm just relaxing, so I'm yawning a little bit. Grab a mug here. Cheers. Glad you could join us once again, Tim, from the UK. Let's see. Galaxy groups, a 2-mass catalog. See, I mean, a lot of these galaxies and objects in the sky are going to be part of surveys. They're going to be part of some kind of catalog. X-ray scaling relations of core and coreless E and S0 galaxies, elliptical and very, very tight spiral galaxies. Okay, scaling relations. A catalog of visually classified galaxy in the local universe. Okay. Morphological analysis of galaxies taken with Spitzer. Hunting for supermassive black holes. Everybody's really hyper ventilating about all of that. Stellar structure in galaxies. The ultraviolet catalog of Galax nearby galaxies. Cool. Extremely deep optical images. So that is sort of the same kind of thing that we were looking at before. Let's see if we actually have an image of our galaxy in here. I would like to see a nice deep image of this beautiful elliptical galaxy NGC 5576. I would like to see one. So let's give it a try. Let's give it a try. Glad everything is okay over there, Tim, for you. Hope you're keeping busy, hopefully not too busy. Hope things are going relatively well. Okay, so let's just do a quickie look here. So 5576 is not coming up in the text at all. I'm not too happy about. So here they're just talking about their techniques and what data they used and all of that. Let's get into the real deal here. See what we can see. Wow, look at that. Look at that. That's crazy. That's some crazy stuff going on there. Wow. What is that? NGC 474. Wow, that's some crazy stuff going on there. All right, let's keep going here. 3489, Megacam, 2592, 2594, 7457. Dang it. Probably have to look it up on a table somewhere. Yeah, because we're not showing off here. Structures being revealed after subtracting a galaxy model. So here they've actually tried to let's see here. Okay, yeah, so they've taken this data and they've created some kind of model and then subtracted that out to just, you know, you're looking at the difference of those two things, and so, you know, there's some funkiness with the model, of course, because models are never perfect. This is what I mean about uncertainty. You know, you start with this, you create a model, you subtract all that out, and you get this. Still some weird stuff in there, but yeah, you know, it's very revealing, very, very interesting, of course. NGC 448, it looks like. Some beautiful galaxies, of course. What was the UGC number of this guy? It was 90 something. 9183. No, not going to be there either. Not going to be there either. So, wham. Okay. Come down here. They're showing all these galaxies, but they're not showing 5576. Isn't that just... Okay, here we go. Here we go. 557476. So which one is that? I think it... Is it this one? Clockwise. Okay. 770. 680. 2698, 2699, 5507. No, I did that wrong. 1, 2, 3, 4. Huh. Wait a minute. There's... Oh, maybe there's only 5 images here. Yeah. So the last one is this one. So I think this is it. Let's confirm that. We need to go back to sort of an SDS image here and see. Okay, so we've got... Yeah, I think so. 'Cause there's that bright... Yeah, I think so. See, there's these two bright ones here and a fainter one here. Two bright ones here and a fainter one here. And this one has a bright one up here, and then it's got a galaxy up here too. Is there a galaxy there? If there is, we got it. Yeah, there is. Okay, so that's it. Yay! We actually have a deeper image, and yeah, wow, what's going on there? I think this little one here is oh, we lost our... I think this is 5574 and this is 5576. So yeah, look at all that stuff flying off of there. Wow. Something interesting is going on, of course. Yeah, prominent tidal tails, as they say. So cool. Wow. Okay. Well, wow, we haven't really dove into these papers too much. I don't remember where we were. Early type, H alpha imaging. We were somewhere around here. Mega maser, X-ray halos. Yeah, we were somewhere in here. I don't remember exactly where. I thought it was 2015. We can do this too, 5576. Forgot about that. We can just see if there's any papers specifically about that. Oh, there aren't. So there, out of those 291 papers, none of them are specifically about NGC 55776. But it sure has been observed quite a bit and used, those observations used in a variety of different ways. So pretty cool. Pretty cool. Oh yeah, the super interesting things were just tying up my head way too much. So it was just easier, just to sort of let loose of everything, let all that excitement pass. That excitement has all passed now. There's a couple opportunities that I wanted to focus on, and they did not come to light. So that's okay though. That's all right. It's when doors close, other doors open, and that is sort of what's taking place now. Is that a few other interesting doors are beginning to open. So yeah, everything's good. Everything's good. I'm not going to complain all that much, and even if I do, nobody really cares anyway. So okay, well, cool. I think I'm looking at the time, and I'm noticing that we're a little bit past. So I think that we've taken a relatively decent look at this object, NGC 5576. It's got some interesting characteristics for sure. I sort of have a slightly better understanding and appreciation for why it's been studied as much as it has. It's nearby. It's massive. It's got some interactions going on. It's got a good view of sort of the central region, and so everybody that's excited about black holes and all of that, can really dive into it well. So, all right, I'm going to take my last big gulp of this, and then I'm going to get on out of here. Cheers. All right, that's the end of that. Must be the end of the live stream. So yeah, all right. Well, hope everybody does well in the next 23 hours. I'll be here again tomorrow, 22 hours UTC, a little less than 23 hours from now. So just one little rotation of this planet. Check the chat again one more time, really quick. Yeah. Hey Tim, I've seen some of the videos that you've made with your new 3D printer, and yeah, it's it looks like really simple, like you just sort of push the button and it just prints this, but I know that it isn't like that at all. So yeah, hope that is going well. Hope the printing keeps going. That is at least one major thing in the future. I think is going to be printing stuff. Why go to the store, to the hardware store, say, for a bunch of screws, if you can just print them right here, right? Um, I think it's a great idea. So you know, I think that is definitely uh, um, that is going to be further developed in the future, and I think it's great. I think it's um, very, very great. So yeah, and of course you're exactly right. You know, design is definitely the hard part. You got to lay all that stuff out, and you got to be able to think three-dimensionally now. And it's like, ah. All right, everybody, I'm gonna get out of here. I'm gonna pull up my YouTube channel to turn that off, and I'm gonna get out of here. So peace, cheers, and all that. I will see you again, as I said, a little less than 23 hours from now. Don't know what it's going to be. It'll be something astronomical, of course, because that's what this channel, this live stream is all about. So, all right, peace, cheers. Make sure to hit the thumbs up if you so desire. Spread the word. That's what it's all about. I want to share the passion. So, all right, until tomorrow, peace, everybody. See you later. Bye.